Okay, let's look at the homework number 7, problem number 4. Right, so this is a boat problem. All right, so let's look at that. All right, so let's write down what we know. So boat is being pulled toward the dock as shown in the figure to the right. All right, this is the figure. All right, the rope is being pulled in at the rate of 2 feet per second. All right, so let's write that down. All right, so rope is pulled in this way, right, at the rate of 2 feet per second. All right, so we got that. So so 2 feet per second. Alright, how fast is the distance between the dock and the boat? Alright, so we are interested in the rate of change of the distance, so from here to there. Right, so it's a horizontal distance. I'm gonna give it an x here. Right, and the rope, the length of the rope is shrinking, so we need a variable. So I'm gonna give say r. So here, this is r. Right, then we're looking how fast is the distance changing. So we're actually looking for the rate of change of x with respect to time. So it's dx over dt. So this is what we're looking for. Right, and let's see, when decreasing, when it is 3 feet from the dock. So actually x at this moment is 3. Right, 3 feet. Right, so that's come from here. All right, so what we want to do is we have to set up an equation using geometry, probably involving x and r. Right, so there's conveniently a right triangle here, so let's use a Pythagorean theorem. Right, so Pythagorean theorem states that x squared. All right, so we have Pythagorean theorem. Maybe I write that down. Pythagorean theorem, right, gives us that x squared plus, right, this guy squared and that guy squared, so it's going to be 3 squared is equal to length of the rope squared, so r squared. Right, we have that. And then what's given is, let's see, let's write that down. Right, so x is, in this case, 3. Right, and here, this is a rate of change of r, so this is dr over dt, right? But a little bit careful, since the rope is pulled in, the length of the rope is actually decreasing at the rate of 2 feet per second, so it's a -2, right? So we have dr over dt is equal to -2, right? And we can use the Pythagorean theorem to find r. Right, so what's that? So r is going to be, let's see, r squared is equal to, right, this guy is squared, so at this point it's a 3 squared plus, right, that this is 3 squared too, so 3 squared, which is going to be, what's this, you have 9 plus 9, so 18, right? So by taking the square root of both sides, we have r is equal to, we don't have to worry about the plus or minus negative because it's a length of the rope, it's always positive, so it's going to be a square root of 18, which is same thing as 3 times square root of, actually, right, it's 3 times, 3 times square root of 2, right? So we have that. Alright, so we have 3 square root of 2. Alright, then what we are looking for is dx over dt, so we have to take the derivative. So let's start with the Pythagorean theorem. Alright, then we're going to just take the derivative with respect to t. So take the derivative with respect to t. So derivative of that is 2x dx over dt, because we're taking a derivative with respect to t, not x. Alright, derivative of 3 squared, since 3 squared is a constant, derivative is 0. So I don't have to write down anything. Alright. Then derivative of 2r, r squared would be 2r times dr over dt. Right? Then since we're looking for dx over dt, we can isolate that by simply dividing through by 2x. So you have dx over dt is equal to, right, 2r over divided by 2x, and you have a dr over dt. Right, and you can cancel 2 here and 2 there. Right, then plug in what we already know. So in this case, r is, we just found that to be 3 square root of 2 feet divided by x. X is given to be 3. Right, and the dr over dt is -2. Right, it's from there. Right, then clean it up. So you have 3 and 3 cancel out. You're going to have -2 square root of 2 feet per second. Alright, so let's type it in. Alright, so it says the distance between the dots is decreasing. So this decreasing takes care of a negative sign. So the feet would be, actually, that round to the near thousands is needed. Okay, so I have to do that. So it is, so come up here. Alright, so it's a 2 times square root of, where's the square root? Square root of 2, right? So that's equal to, right, 2.8. So I'm going to type it in. Let's see, near thousands. Okay, so you have a 2 point, right? So that would be the 10th and 100th and 8. All right, so 2.828 feet per second. Let's check the answer. All right, got that. All right, that's it. I hope that this was clear.